One card is selected from a deck of cards. What is the probability of selecting a face card or a diamond? Here's my deck of cards. Remember, the face cards are the Jack, Queens, and Kings. And what is the probability of me randomly selecting a card and having it be a face card or a diamond? In this case, we have to determine, are these two events mutually exclusive or are they inclusive? So a face card or a diamond. And what you ask yourself is, can I select a card randomly and have it both be a face card or a diamond? And the answer to that question is yes. I could randomly select, for example, a Jack of Diamonds or a Queen of Diamonds or a King of Diamonds. So these three cards here are cards that make these two events happen together at the same time. Okay, so that tells me that these two events are inclusive. And once I determine they're inclusive, I know what formula to use. I need to find the probability of A, the probability of B, and then subtract the probability of A and B, which is the intersection or the cards that I'm counting twice. Now, before we continue, I want to make a pause here a little bit and talk to you about different notations that you might see in other books. The probability of A or B, sometimes you'll see that as this notation, the probability of A union B. Whenever you see this notation, that means or, okay? And probability of A plus probability of B. For probability of A and B, you might see it like this. It's a probability of A intersection B. Okay, so whenever you see this notation, make sure you know what it is. When you have the upside down U, it's intersection or and. When you have a U like this, it's union. It means the probability of A or B. You add them. Okay, just wanted to talk to you about that notation. Okay, let's go back to this problem. Let's calculate the probability of A. Probability of A is that it's a face card. And we know that there are 12 face cards out of 52. And I'm going to go ahead and mark them here. And excuse my squiggly lines, but it's not too easy to write with this digital pencil. Okay, there is the probability of A, 12 out of 52. Let's look for the probability of B. Probability of B is that it's a diamond. So these are all the cards that are diamonds. And notice that when I circle my diamonds, I'm including 3 face cards that I had already included in my first probability. That means I've counted them, I've accounted for them already, right? So the probability of B is equal to how many diamonds? There are 13 diamonds. 2, 4, 6, 8, 10. Yep, 13 diamonds. So 13 out of 52. Okay, now to find the probability of A or B using that notation I just showed you, that would be equal to 12 out of 52, which is the probability of A, plus 13 out of 52, which is the probability of B, and now I have to subtract the probability of A and B, which means the probability of those cards that are both diamonds and face cards. That's what it means. And the cards that are both diamonds and face cards are these 3 here. So these 3 cards, I already counted them, so I have to subtract them because I'm counting them twice. I counted them here when I said 12, and I counted them down here when I said 13. So now I have to subtract them out. 3 out of 52, and that gives you a total of 22 cards out of 52 cards. Okay, and we can verify that. We can count. If I say the probability of A or B, let me change colors. Let me use red. Here. These would be my cards, right? This set here. Whoops. Just trying to show you group of cards. So there it is. Notice that I've encircled here the whole group of cards as one unit, and I get this sort of like a sock shape or L shape or boot shape. And when I count my cards, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 cards out of 52 that fit the description of these events, that they're either a face card or a diamond. And you can go a bit further with 22 over 52 and get 11 over 26, and you can find the decimal approximation to this or turn it into a percentage by multiplying that decimal times 100. Okay, I'll leave that up to you, and we will see you in the next video for another example.